In the first video we shot for fall protection, we looked at the overall OSHA impacts to 100% fall protection on steel towers. This video we're going to focus more on steel towers, what kind of methods we can use, and equipment that we can use to move around on the towers and facilitate our work. Hi, I'm Dave Kadich, one of Western Area Power Administration's fall protection coordinators. With me today also is James Hill. He's the other Western Area Power Administration fall protection coordinator. We also have joining us in the tower today is Charlie Garcia. He's Western's senior structural engineer. Charles is going to give us some tips on where to anchor in the towers and some things we need to look at from an engineering standpoint. All right, Charlie, how long have you been researching and studying transmission structures on towers?
Been doing towers for Western now for 27 years. The lattice structures, the comm towers, substation structures, all the steel structures.
So as a structural engineer, Charlie meets with us on occasions and we review where we can and can't attach in the steel towers. Let's go over some of the equipment that we're using in the tower today.
So what I'm using today is a lifeline, 30-foot lifeline, also known as a cow's tail or a monkey's tail. Attached to it's my mobile fall arrestor, the ASAP lock, and it's attached to a horizontal member that's double lattice steel, so it's going to meet the 5,000 pound anchorage requirement with a sling. Charlie's also hooked up in the same fashion but with a shorter 15-foot cow's tail, and as you can see he's also hooked with a 6-foot Y lanyard with the big butt snaps to a horizontal lattice member here. Dave is hooked with a shorter Y lanyard with the big buck hooks, but as you can see here, this double lattice steel setup right here is too big for his buck snap to go over. So Dave has improvised and used a sling that's 5,000 pound rated to hook into for his continuous fall protection. When you're hooking your big buck snaps into these, you want to make sure, as Dave has in here, and Charlie as well, that they're orientated basically in a vertical position so that there is a fall, the fall forces fall directly in line with the hook. What you don't want to have done is have them in a perch position to where the fall is going to bend your hook in half, because one, it's probably going to break your hook, and two, it's against manufacturer's recommendations.
Hey Charlie, so from a lineman perspective, when we're in the tower, we're primarily concerned with where we can't attach. So from your perspective as an engineer, where are the places we should be looking at for the most safest places to attach?
Today we're out here on a 51N. It's a dead end tower, 500 kV. So you got a lot of big members in here, like we're attached here on our vertical lifeline. It's a double angle member. It does have a single bolt that's attached to the leg, but it's in double shear, so it's twice as strong. So this is a really good member for strength. Also, this member right here next to me, it's above my D-ring here, and I'm attached on the end. This one it's a little different, it has 2 bolts on the end, one on the other side, but even one bolt is strong enough. The bolts will shear over 10,000, so there's no problem for attachments on them. This angle is strong enough even in the middle. This is the weakest point right here to be attached to on the tower, because the angle is the least strength and it's more likely to bend. This member is a little bit bigger, but some towers are going to have real small members on here, and if you do fall into this member, it's going to be weak right here. So we have a lot of big members. This one we're standing on is a nice big angle across the tower. It has double bolts on either end on it, so this one's strong. The legs, of course, all the diagonals are big because it's a tension tower. We got tension insulators on it. If it were a suspension tower in a light loading zone, we'd have a lot smaller members, more single bolts we have to worry about to be careful on.
On these members here, Charlie, can we move more than one person out in the center, or we want to stay away from that?
No, you don't want to have more than one person in the middle of an angle. Keep them on the ends. Like I said, this one has 2 bolts on one end, one on the other, so it's still a 1 bolt connection. It's stronger on this end than that end, but don't put 2 people in the middle of a member like this. You want to keep one and then keep them on the ends.
Now on our vertical lifelines, we're both attached to the same member up here, but that member up there is 2 members bolted together.
Right, it's double shear on the bolts, so the bolts are twice as strong.
So when we go thinking about a fall protection anchor, in this case, we can go to 10,000 pounds fall arrest for both individuals because we have two members bolted together, increasing the capacity.
Right. I'd try, I mean, it's hard to do, but I'd try and stay away from putting both people in the middle of this one too. But it would still probably be okay to have both people there if you had to. But try and stay on the ends of these members, especially the longer the member, the weaker the member is going to be in the middle. So that's something else too. Even if it is a big member, if it's spanning 50 feet, it's still going to be weak as this small member is spanning a short distance. James was asking me a question too on this member we talked about earlier, because there's a bolt over here. It's a single bolt, but then we got this member that I'm sitting on right here that's coming up to it. And I guess the question was really, is this member right here, they're all separate members, so this one doesn't really affect anything. If you were to fall, you're really only looking at one member at a time, and it shears through the bolt right here where it's attached on this one side only. It doesn't affect this member at all because this member's on the back side. They would have to shear through the bolt in a different place. So it doesn't help it, doesn't hurt it, doesn't do anything with this other member here attached to the same bolt. And like I said before, this one's a single bolt, on the other end is a double bolt, and the member going up from it has two bolts on it too in the same connection, but it doesn't change anything with this member because it's really only the bolts on the end that actually affect it, with each member separate.
So Charlie, speaking upon the steel and stuff and the bolted connections, which is stronger? Is the steel itself stronger than the bolt or vice versa?
It's the bolt all the time, and that bolt right there on our transmission line structures, it's all laid out all the time on design to shear off around 14,000 to a little bit higher, depends on the actual size of the angle on how it shears through. But the bolt's always stronger. So what happens is we always want, what I always try and do, like now that I'm up here, is always stay by a bolt so I can shear through the bolt. And we want this angle to shear right through that bolt. That's the strongest thing you can have, and it's way stronger than 5,000 pounds. This angle here, if you put a weight in the middle like we were talking about, it starts to bend the angle. And once it bends the angle, it's twisting. So we got like a lever arm. You got some actual moment going on, and it's easy to rip through the angle itself and leave the bolt there. So you'd actually rip the angle off the tower and the bolt would be fine if it actually failed. And that's why this point is so weak, is weaker in the middle, and the minute you go to the end, you don't have any moment. Just like you'd use in a shovel or an axe, you don't have a lever arm right here. And the longer the lever arm, the worse it gets.
We get a lot of questions on where to hook your mobile fall arrestor on a vertical lifeline when ascending or descending towers. The two options that we're using here at Western are on your dorsal or on your sternal. The option I'm showing right here is having it hooked on your dorsal D. And some of the reasons for that is that you almost don't have to tend it. It would just carry on beside you, depending on how your vertical lifeline was placed, it would travel up and down with you, hopefully unhindered. The other option that you're going to have is having this hooked to your sternal D. And having it hooked to your sternal D allows, one, easier access for the individual. Instead of having to have a helping hand put it off and on, you can have it in front for you to take it off and on, and then you'll be able to mind it with your arm and physically watch how it carries going up and down the rope. With it hooked to your dorsal, it's behind you, so seeing those type of setups is obviously going to be more difficult. And that will also depend on where the rope is. Today we have the rope offset to the inside, which carrying it up on a layback of a tower may be a preferred option, and I like to carry mine in front, and I can mind it under my arm. If it was carried onto the opposite side of me, I may want it hooked to my back, because if I mind that on my arm with the vertical lifeline running in front of the step bolt, has a tendency for the absorber and the device to catch on the step bolts as you go down with it hooked to the front. So hooked to the rear may be a better option.
So with vertical lifelines, one of the benefits that we have here is we have a lot of horizontal movement. Although we're secured at an anchor, this gives us much more flexibility to work in locations around the tower. A 6-foot lanyard, you're still limited by its distance and where the buck hooks go, so you can't reach as far or work as far in one setup without having to move. So James is going to demonstrate what we have here is he can move around the tower quite freely with this setup, as you can see.